conclusions are based on faulty data, then your conclusions won't stand, they're rubbish. We need to be able to find the data. So, here's the research data life cycle. I got told I had to show this, so here it is. So, as I said, researchers are used to dealing with these three green blobs here. They are used to creating data, they're used to processing it, and they're used to analysing it. And often that's all they need to do. They run the experiment, they take their data, they analyse it, they write up a paper, end of story, as far as they're concerned. Preserving and giving access to data isn't something that researchers generally do. And that's where they tend to farm it out to data repositories or institutional repositories. And then we have the whole reusing data, which can be done by third parties, but can equally be done by the originating researcher 10 years down the line when they've gone back to their data set to do some extra work on it and realise that they can't, they haven't documented it well enough for what they thought they'd remember, they can't. So, you're always going to get this question, what is a data set, right? Data sets have a definition, and their definition says it is recorded information regardless of the form or medium on which it may be recorded, including writings, films, sound recordings, pictorial reproductions, drawings, design, or other graphic representations, procedural manuals, forms, diagrams, workflow, charts, equipment, descriptions, data files, data processing, or computer program software, statistical records, and other research data. So in other words, a data set is anything you can possibly think of, right? In my opinion, a data set is something that is the result of a well-defined process. It is, because I'm a scientist, I trained as a physicist originally, I think it has to be scientifically meaningful, but it could be just as meaningful from an arts and humanities perspective. It has to be meaningful. And I maintain that it has to be well-defined. It has to be very, very clear what is part of the data set and what isn't part of the data set. If you've ever created a data set, and I know that some of you have, you know that it is hard work. You spend years of your life on this. And oftentimes you distill it down, you spend years, you write it, and you collect it, you interpret it, you analyse it, you write about it, and then at the end of the day you have a graph, and other people look at it and go, is that it? And people just don't get, unless you have actually gone through the process of creating a data set, they don't get what it is and how much work goes into it. And oftentimes when people say, where's your data? I want to see your data. They don't actually want to see your raw data. They want to see your analysis or your graphs or your notes or something like that. And then, even then, they expect you to kind of explain it to them. So, dealing with data is tricky. So I'm going to give you an example from my own personal experience, because I didn't always work for the British Atmospheric Data Centre. When I started work as a researcher, fresh out from university, I got hired to work with a particular experiment. So basically, I was creating a data set, and it was a radio propagation data set, which means that there was a satellite, Littlesat F1, up there in geostationary orbit, and we were taking measurements of the beacons that it had on it. Because the beacons were at the radio frequencies that if you get a rainstorm or a cloud in between your satellite and your receive path, your signal goes out. And that's not very good for if you wanted to kind of use that particular frequency to broadcast, say, the FA Cup final. People might get a bit annoyed. So we had an experiment. We put instruments out in the field. That's our receive site up there, the porta cabin, and those are our receivers inside the porta cabin. This is an example, just a graph, of 1 day's worth of raw data. It was a particularly horribly wet day. It rained a lot, and you can tell because the black line with all the jaggedy bits, that's the signal, and you can see it drops out all the time. Even then, at the bottom there, it drops out so much that we've lost the signal completely. So that was 1 day's worth of data. These data sets span years. I had to take each day, run it through a number of programs, which were written by a colleague of mine, and you took that, turned it into that, and then finally, at the end of it, came out with some nice cumulative distribution curves. This process took 4 major steps, 4 different computer programs, and 16 intermediate files for each day of measurements. Each month's worth of collected data took me somewhere between a couple of days and a couple of weeks' worth of effort, depending on how rubbish the weather was. And it wasn't something that I could put the computer on and set it going, because the computer didn't know what it was looking for. It wasn't clever enough. It had to have a human's eyes on it. I spent far more of my life than I care to remember doing this. Right. This is how not to preserve your data. This is the Eutelsat data archive on CDs on a shelf in my office. Right. This is the point where I hold my hands up and say, yes, I did it wrong. Definitely wrong. This is what the process data set looks like on disk. There it is. A whole heap of file names. You might be able to guess that there might be a date in there somewhere, but who knows? And what the hell is a .000 extension when we get right down to it? Luckily, these ones happen to be ASCII text. So when you open them up, you can actually open them up in WordPad. But then you look at them and go, what are these again? I do have documentation. Here's the documentation, or some of the documentation. You can't read it, but you'll know that there's a bit of a flowchart thingy going on there, and there's a software file names in the documentation. I still have the ideal files that I used to create the software, that were the software. I have absolutely no idea if they will run in current versions of IDL or not. There we go. So, documentation, it can produce some mixed feelings, right? Because what everybody wants out of life is to be kind of an expert, really. They want to be felt like they're important, they're indispensable. And oftentimes, in the cut and thrust of the economic climate, often knowing that you are indispensable, that you are the only person who understands this very important data set, that's really good by way of job security. So, that is my example. This is my past. My data organisation was horrible. It was bad. And I wasn't even preserving my data properly. As for given access to it, I spent more months of my life than I care to remember spending time working with the legal and contract people in the departments trying to figure out non-disclosure agreements. I'm not a lawyer. I never wanted to be a lawyer. If I wanted to be a lawyer, I would have gone to law school, right? It was a pain. Sharing was difficult. And it wasn't. I was wet behind the ears. I was a newly made researcher. The head of my group was very about the prospect of making it all open data, because this was a few years ago when open data really hadn't made its way or made itself felt, but also because in theory at least these data sets could have been commercially valuable. We never managed to sell them, but in theory they were valuable. And I felt like I didn't get the credit for all this work I put into sharing the data and documenting it and archiving it and all the rest of it. The very first publication that was based on this data didn't have my name on it at all. I had given this to a PhD group, or a PhD student, by request, and we got named as a group in the acknowledgements. I didn't get a personal mention at all. My only consolation is the fact that that particular paper has had 2 citations since, right? So it's not exactly been that impactful. So the good news is, I have seen the light. After a bit of poking and being told, put your data on the BADC or else, the data is all on the BADC now, which means I don't have to worry about it anymore. It is there are people there who will manage it for me. Okay, so any issues in the audience? No? Oh dear, this analogy could go really, really flat then. Yes, there's one. Okay, so, my scarf. So this is kind of, because data sets are so varied, I kind of thought I'd come up with an analogy for why a scarf is like a data set. So you can think about data sets. So, how is my scarf like a data set? The raw material, the wool it's made from, it doesn't contain any information, it's just all rolled up into a ball. But the process of knitting encodes the information into the scarf. So the scarf is the result of a well-defined process. It's very clear what the act of knitting actually does, and it has a particular method used to create it. I need to be able to describe my scarf. I need to be able to find it. I need to store it properly so that it doesn't get lost or corrupted, so it doesn't get eaten by mice or moths or anything like that. I keep information about it because I might want to recreate it someday in case I do lose it. And possibly the most important thing is I've put an awful lot of time and effort into making it. I'm very personally attached to this scarf. For scarf, think of something that you've created yourself. This could be a garden, or it could be a document that you've written, or it could be a Lego model, or it could be any other sort of model. Something that you feel like you've personally invested and put a lot of time into creating. It's that sort of feeling that you get. Just like not all scarves are the same, not all data sets are the same. Just because somebody says, oh, I've got a scarf, don't assume that you know exactly everything about that scarf just because they say scarf. Because scarves come different shapes, different sizes, different colours. They're used for different purposes. They're made in different ways. And the thing here is, data sets are like that. If somebody says, oh, I've got a data set, don't automatically assume you know what that data set looks like or contains. If in doubt, talk to the person who has the data set, ask the creator, get the information off them. Right, metadata. So, metadata is important because we need to be able to describe things. So the example here is that we need longitude and latitude about the planet. It's to be able to locate us on the surface of the planet or locate things. So longitude and latitude are artificial. You're not going to find big, massive lines drawn along the lines of longitude and latitude. But we artificially put them there, and we've arbitrarily put them there, but we are using them as a consensus. And they allow us to communicate